Hello and welcome to this episode of Microchips and a follow-up from the What Rubbish Have I Bought Now video. The first one, there's a link in the top corner if you want to see the first reactions on that. But anyway, let's get to it. So, this Harvard 410, when we opened it on the previous video, we suspected somebody's reverse polarity'd this because the audio amplifier was, blasted apart. The main smoothing capacitor was blasted and must have really gone with a good bang to spread its guts all over the place like that. So somebody's reverse polarity'd this and it's gone with a pop. But the underside of the board looks okay, no burnt traces, no surprises there. So let's see if we can resurrect this just for the fun of it. So we're going to have to get rid of the remains of this capacitor and try and find out what it was originally. And we're obviously going to have to get rid of the remains of the audio IC as well. Now luckily the audio IC is readily available, so we'll be able to put one of those back in, which I have ordered. So we just need to tidy up this area, get rid of these blasted remains of this capacitor. Yeah, that must have gone with a fair old crack. I'm trying to get it out so I can actually see what the value was. I'm trying to just pick bits out of it. Well, it looks like it was a 220 mic sometime in its life, but not anymore. So I should have one of those, so we can replace that. And we'll clean up all the debris from the board, like that. So it's looking a bit better already. So there's our new capacitor in. Now we just need to fit an audio IC, which are nice and cheap and readily available. Just a standard audio IC used in many applications, an LM386N, nothing too special. So there it is in place. So let's see if the radio does anything. Turn the display on would help. Sure enough, the radio comes on. And it's doing something. And we all know that transmit meter is a fake. Let's just listen to it on another radio. So we've got transmit. It's drawing the correct amount of current. So it looks like our very rare final output transistor has survived. And it is receiving. But it's got no audio. That noise you can hear is from my other radio. But it thinks it's receiving. We've just got no sound. Nothing. Not a crackle. Absolutely nothing. But we have a strange pop. Almost looks like there's DC on the line somewhere. So I was measuring around the audio IC with my meter and I'm getting 12 volts in places I shouldn't be getting 12 volts. And I really thought this was a real head scratcher. So do a bit of basics, we'll check input. And sure enough, we have input. So we know that part of the circuit's working. Or is it? So, looks like a decent enough audio signal coming from the volume control, which pipes itself straight into the audio IC. So it looks like we've still got a problem with the audio circuit somewhere. So these were the points I was monitoring on the scope, which should be the inputs. So I thought I'd found a dodgy capacitor, but no, led me up the garden path. So I'm actually testing the audio ICs now in another handheld I was using, just to make sure that those audio ICs were working. So anyway, this is a little bit later on, actually a good few weeks later on, and I decided to diode test the area around the audio IC, and I found a discrepancy on pin 5. And pin 5 goes into the demodulator IC, the 3357. And sure enough, changing this chip cured the problem. So 12 volts must have gone from the audio IC and blasted this chip as well. But this wasn't the audio output of the chip, this was a mute or an enable. So it must have just been holding the audio IC in a strange state. But as you can hear, it's now receiving. It's on frequency. And there we have it. It's working, finally. So, the reverse polarity took out the audio IC, took out the smoothing capacitor, took out the 3357, and luckily the PLL chip is behind the regulator, so that survived. But anyway, hope you enjoyed the video. Don't forget to like, subscribe, join the Facebook group, buy me a coffee, join Patreon. Thanks for watching, and we'll see you in the next video.